Hey guys, so today we're going to make a game in 88 assembly, specifically a number guessing game, guess the random number. So we're going to be doing random number generation, we're going to be doing conditionals, we're going to be doing input and output, and we're going to be doing ASCII to integer, all in 88 assembly. So I'll show you how I do it in C, and then I'll take that C code and turn it into 88 assembly, run it in CPM, and we'll have a game. So for starters, we're going to be using gvim, because why not, and we're going to be writing the C program. So let's do the headers first. Include stdio.h, include stdlib.h, that's for atoi, include conio.h, that's for kbhit, and include string.h, that's going to be for memset. So then we do our void main. Okay. Okay, now let us try compiling it. Looks like compiled, and let's continue on. So let's do the first bit. We're going to first put as start text. Okay, we're going to put our welcome message up here. So char start text random number generator, random number guessing game. And then I want to do new line, so we'll do 12 and 15, which is A and D, new line carriage return. And press any key to continue. And there. That's done. Okay, so now if we write that, we compile that. I have no idea why that took so long to run, but that did. Okay, so that works. Now, let's continue on. Let's do increment rand, right? Because rand until key is hit. And what is rand? Well, rand is going to be an unsigned char rand. We're going to set it to 0. Actually, you know what? We're not even going to set it to anything. Okay, so then a do while. Okay, so do rand plus plus while not kb hit. And kb hit is a function. So basically, kb hit returns 0 unless a key is pressed. So that's what we're going to do. And we are going to do something that we're not going to do in the 88 assembly version. We're going to do a garbage getS. Clears buffer, clears stdin. Because what ends up happening is that when you hit kb hit, there's still something in the buffer. So I need to do a garbage getS to clear that buffer, even if it's just an enter key. So let's do getS inbuff. And what is inbuff, you may ask? Well, inbuff is the input buffer. So let us make our input buffer. Char inbuff. I'm going to make it size 8. Okay. then let's try writing it. Do a quick compile. Yep. Never mind, it seems like it would be way too much trouble than it is worth. Anyway, let's carry on. So after the get s, put s, prompt text, and let's do that up here. Char prompt text equals enter or guess 0 through 255 because I have a cycling byte. Okay. And then so grab user grab user input. So this is going to be get s inbuff, right? Okay, that's going to be get s inbuff. And what I'll actually want to do first is I want to memset clear inbuff. Memset inbuff 0 size of inbuff. The reason being is because I will do a loop, and I will do that right here. And I know before you say loops in C are, go-tos in C are gross. Remember, this is C in specific, with specific mind to convert to assembly. So I think we can, take some liberties with our C code in this case. Okay. So, because every time we do an input, we need to clear the input buffer, because maybe you guess 200, but then you guess 10. But the problem is that last 0 from the 100 is still going to be in the buffer. So when you type in 10 and hit enter, it's actually going to be 100. So you want to clear it all first. Then I need to do atoi. Reg HL equals atoi inbuff. And what is reg HL? Well, reg HL is going to be short for short reg HL, which is going to be a 16-bit number, which eventually in the assembly will be the register pair HL, which is also going to be 16 bits. Perfect. So then all we have to do is compare reg HL to rand. And let's do it. So if rand is less than reg HL, and you will see why I do it this way in the assembly. If I did a reg HL greater than rand, obviously it'll work out the same. It's just that the flags in 8080 assembly just work out a little nicer if you do it the opposite way. You'll see, because rand is going to be in A, and I'll be comparing against another register versus the other way around. Yeah. So put S. Reg HL is going to be too high, right? So too high text, and then go to loop. So it'll jump back to the loop. And what is too high text? Well, that's pretty easy. Too high guess again. Okay, and then let's do char too low txt equals too low guess again. Okay, and then what happens if you win? You won. There we go. Okay, so then let's do if rand is equal to reg hl. Let's do put s win text and then return, because this is in main, there's no calling anything, so return will pop me out of the executable. And then if rand is greater than reg hl. No, I probably don't need this last check, right? Just remember that I probably don't need this last check. So if you want to make your code smaller, you don't need the last check, you can just do the stuff. Put s to load txt and go to loop. And that is it. There is the game. There's the number guessing game. So let's write it. Let's compile it. And let's try it. Okay, so guess number between 0 and 255. Let's say 100. Too high. Okay, let's try 50. Too high. Let's try 10. Too high. 0 is too low. 4. Too low. 5. Too low. 7. Too low. 8. Too low. 9. I won. Cool. Okay. So if you notice, I don't have a counter that will like, oh, you took 89 guesses to do this, but that's something that I will leave for you to do, because I will show you how to turn this C code into 8080 assembly, and then you can build off of it and make it real cool. Okay, guys. So I just erased all the old RAND programs from my CPM machine, CPM virtual machine, because I don't want to be cheating and using, what I've used before. Let's try it. So number guessing game, right? This uses a time RNG. Users key input is random to the program, because the program doesn't really know when you're going to hit the key, right? So it'll just keep incrementing and overflowing until you hit a key, and boom, that's a random seed. In fact, you can see this in Rogue. If you ever play Rogue on CPM, or even in DOS, the title screen for DOS is a random number generator. It's constantly incrementing. But when you run Rogue on CPM, it'll say press any key to continue. That's exactly what it's doing. It's creating a seed. We're creating a seed. We're using just the seed for the random number. We're not doing any algorithm to make the seed more random. That would work. You would need that if you want to do many random numbers consecutively. We only care about one because that's the one you're guessing. You're not going to do multiple. So I wouldn't worry too much about it. Let's do the boilerplate here. Yes. Is equal to 5, and the drill is equal to 9, read is equal to 10, and read size, which is going to be the buffer size for your input. Well, if you look over here, our input buffer was 8, but let's do 10. And let me tell you why I did anything greater than 3 to begin with. I only need an input buffer size of 3 because the number that can be guessed is only going to be up to 255. Those are only 3 digits. But with CPM, if you're not rolling your own getS routine and you want to use the BDOS routine, once you hit that 3 character limit, if that's what you say, is like max 3 characters, then it will instantly pass through. It'll instantly fall through and continue on the program without you hitting enter. I want you to hit enter because it makes sense. Also, you might guess like too high or something, and you might want to back up and edit your number before you hit enter. So it's just a convenience thing. It's a modern thing. It's just, why do it any other way? And remember, I do 10 instead of 8 because the I do 10 instead of 8 because remember this, it's essentially a struct, right? It's essentially a struct where you have your max size, you have your actual size of how long you've typed, like how long the strings that you typed, and then finally you would have the then you would finally have the character array of what you typed. So that's what this is. That's what this is going to be. It's going to be inbuff ds right read size plus 2. Okay, so that's what that's about. Okay. Okay, and then okay, let's start writing. Org 100h. That's where everything good starts. And we're going to do mvi a read size. Why am I doing that? Because I want to store the read size to the first byte of inbuff. So let's do that. And then store into inbuff. I don't need to store through indirect or anything like that. Okay. So remember this is and read size. Essentially, there's no direct C equivalent to this because C handles its own things itself. But of course, put as start text is going to be this lxid start text call put as. Okay, and then where's put as is down here. Simple like that. There we go. Okay. Now, let's do this. Sorry, I was just thinking here. So this is going to be the do rand plus plus while not KB hit. Okay. The reason I can't do an exclamation point in the comment is because it breaks the comments. CPM assemblers be wild, man. So let's do this. R loop, right? Random loop. LXI H rand, and rand is going to be down here. Rand db 0. I'm initializing it to 0 down there. So I'm now pointing H to rand, and then I can do increment register M, because remember M is the contents of what HL points to, and then call KB hit, and then compare against 0, and then JZ R loop, right? And then KB hit, well, what is KB hit? Well, it's down here. KB hit, MVI E 0FFH, that's the flag, MVI C 6, call BDOS, return, boom. Okay, so there's the do while loop. And then of course I need to do put as prompt text. Okay, so this is where I'm going to like now you got to input a number, right? Because that's what it says over here. Enter your guess. So let's do that. LXID prompt text call put as. Okay, And then let's do that down here. Also, let me, before I forget, let's do this. Let's do this too. So text, random number guessing game. 0 H 0 DH. Press any key to continue. And of course, remember this: the put s doesn't have the new line routine, so just put that in yourself. And then put in prompt text. Enter your guess. By the way, this is enter you guess. Enter your guess. Enter your guess. 0 to 55. And of course, I want to put a new line at the end of it, or else it'll be gross. It'll look pretty gross if you don't do that. Okay, there we go. That's the prompt text. And then let's do the main loop, right? So loop. And first, I got to, well, after you do put as prompt, we don't need that garbage. We need to do a memset. So let's do that, right? So memset inbuff 0 size of, oh my god, inbuff. Okay, well, let's do it. So LXI H inbuff +2, and remember the +2 is because I want the char side of inbuff. I don't want to mess these up. Okay, and then let us VIC read size -2. That's how long the char read size is, right? Because read size is a full thing 10. I only want 8, so there we go. So we have HL, C is the counter, and then MVIA 0. You know what? XRA A, just clear the accumulator. That'll take up less space. Move A to M. I'm looking at my notes and I have it backward. Like, I'm losing it. Okay. So there we go. And then increment HL, decrement C, and then, right, jump if it's not done, right, jump if it's not done, to loop plus 5, right? Yeah, I guess I could do +6 because I don't need this extra resetting A every time, but who's counting? I really don't care. There we go. Okay, then I need the getS inbuff. GetS inbuff. It's just funny, like when you rewrite code, like you just see all these ways to like optimize it and just, just do better next time, LXID inbuff, right? And then call getS. And what is getS? GetS is MVIC read, call BDOS, return. Okay. And then what is this? Reg HL equals atoi inbuff. Okay, here we go. And then LXI D to inbuff again. Maybe I don't need to. Maybe getS preserves it. I mean, it's one of those things you just have to think. One of those things. Call atoi. And what is atoi? Well, atoi is going to be the wonderful atoi routine I had before. So let's just bang this out. Inst d LDAX D. This is going to grab me the counter. Inst D. That's going to be pointing D now to the beginning of the characters. Move the counter to C. Move set HL to 0. Clear the carry flag while keeping the accumulator not destroyed. And then return if 0, right? Because this is going to be points of atoi loop. It's going to be right there. Okay, push B to preserve that call mul10. And what is mul10? Mul10 is down here. Push B, pop B, return. And what is I'm going to do? Move H to B, move L to C, double add H, double add H, double add B, double add H, H, B, H, pop B. Cool, and that's how you multiply by 10 pretty easily. Okay. Call mul10. So then LDAX D SBI subtract 30 H. First ASCII move accumulator to C. Clear accumulator. Move accumulator to B. Increment DE. Pop B back onto the stack, increment the counter, jump atoi plus 8, return. I think that's it. CBDB, CBD. I'm just looking. C30D mul10 B RZ. Okay, I'm just making sure I have my atoi written correctly, because that would be a pain if it wasn't. Okay, so let's go back up here. Where were we? Right, okay, we were right here. So after the atoi, I want to do if rand is less than register L, but technically HL, right? I only need to compare against HL, or only against L, because it's 1 byte. It's a 1 byte guessing game. So LXI D rand. Okay, so I'm loading, oh my god, I'm loading the random number to D. And then I will do LDAX, so I will load what D points to the accumulator. Okay. Compare to L, and then JC to high. And JC will jump to the to high routine if, in fact, you guess too high. So what do I do the too high? LXI D, push D, pop D, return, LXI D, initiate text, call, put S, and pop B. Okay. And then too low. Okay. Oh, right. And instead of return, you want to go to jump loop, right? There's no return. It's not calling anything. Jump loop. But then win. And this will have a return because you want to quit the game once you have guessed the correct. So let's go down here. Let's go up here. Prompt to AGH text B. What is this? Too high. Yes, again. Okay. Too low. Okay, and then let's see. You won. Looks good. Okay. Too high. Okay. And then what is this? If rand is equal to reg L, then I gotta compare it to L again. JZ win, right? Jump to the win. And then if not, implied if greater than, and that's going to be J and C too low. Now I might not need this for the J and C. Maybe I can just put this up in its place, but who knows? And then I don't need the return because that will never be reached, hopefully. You know, let's save it, let's read it, and let's see if it even assembles. It loaded and it assembled. Let's try running it. Press any key to continue. I'm going to hit enter. I'm going to type in 200. Too high. Okay, let's try 100. Too low. Okay, let's try 150. Too high. 120. Too high. 10. Too low. 115. 113. Oh, shoot. 16. 118. 117. You won. Okay, so that's pretty awesome. Now where it says guess again, see how it didn't do a new line? That's because I don't have these leading them. If I put those in front, I'd also be able to see what I typed in. Let's try that again. Okay, try it again. Okay, we're gonna type in 100. Too high. Okay, how about 40? Too high. How about 20? Too low. How about 30? Too low. 35. Too high. 33. Too high. 32. Too high. 31. There we go. I have just made a number guessing game in 8080 assembly. Now, of course, this is very rudimentary, right? This is only under 34 lines with comments and stuff. And, you know, there's a couple of optimizations you guys can do to make it a little better if you want. Also, there's no counter. So if you want to do an ITOA counter where you increment, incremented by memory and say, oh, it took you 10 guesses. Maybe you want to do modulo, so maybe you don't want to do up to 255 because 0 to 255 is pretty large. Maybe you don't want to do 1 in 10. Well, how do you do modulo in 8080 assembly? I have shown you some tricks on how to do modulo very cheaply, but I'll give you a hint, it's not in the 8080 series. There also, maybe you want to type in your range that you want to guess to. You have all the parts you need for this game to grow into a fully fledged number guessing game. And I leave it up to you, and I challenge you guys to make one yourself. And I will see you next time.